Hi, this is part one in a multi-part series of short lectures on firing at Metro. So I want to talk a little bit about bisque firing and cones and what they are in this lecture. So historically, before the Industrial Revolution, bisque firing didn't really happen. And when someone was gathering all the wood and firing a kiln over multiple days by putting in, one piece of wood after another and not getting any sleep, obviously you wouldn't want to do an extra firing, a bisque firing, which is really just for the convenience of making your glazing easier. So, but now this is the traditional way that we do it. And so it's part of a two-part process where the bisque firing prepares the clay for glazing, and then you glaze it, and then you put it back in the kiln for the glaze firing. Obviously, if you're not planning on glazing a piece, or you're using slips or other surfaces, or you're putting no decorative surfaces on your clay, then bisque firing is entirely unnecessary, and you can do a once fire. If you wish to do that, talk to me and I'll make sure you have an adequate program to do that. But when we do bisque firing, we tend to talk about cones in the kiln. So cones do somewhat correspond to a specific temperature, and all but two of our kilns in the studio have a pyrometric thermometer that allows you to check the actual Fahrenheit temperature. However, those are a little bit inaccurate. They actually measure the air in the kiln, and your pieces are dense, and so they may be a slightly different temperature. And so the cones are a way of measuring like what we call heat work. It's sort of like the heat in the kiln over time. And that is what's having an effect on your clay pieces. So the cones are a more accurate reading of the actual temperature in the kiln. So cones have a funny system where when they're lower in temperature, the number has a 0 in front of it, and that goes down. That number goes down as it gets hotter when there's a 0 in front, and then when it gets to 1, it goes back up without a 0, and the hottest temperatures are around 10, cone 11, and there's no 0. So I've put up on this whiteboard here a kind of representation of that. Ooh, how do I get this on there? So, cone 010 is about one of the temperatures that we might start thinking about doing a bisque firing. And then cone 09, cone 08. Cone 08 is around, I believe, 1780. Could be wrong about that. And they just keep on going hotter in temperature. Cone 07, cone 06, cone 05, cone 04 is our a very common low fire glaze temperature. Whereas our most common bisque temperature in the studio is somewhere between cone 08 and cone 06. So anyway, the cones go down in number as they go up in temperature until they get to cone 01, and then you immediately jump to cone 1. Then there's a few more, cone 6, 7, 8, 9, and cone 10. Cone 10 is what we refer to as high fire, and it is typically a temperature that we might take a few of our clays to, but not all of them. So the kilns in our studio, we usually do a two-tiered a measurement of temperature. We look both at the pyrometric thermometer and at the cones that should be either manually part of the firing process or just visible through the peepholes in the kiln. All right, so when you're making a piece that's going to be bisque fired, of course, you want to do all the things you can to make sure it's structurally sound. And as long as you do all those things, like making sure there's no major air bubbles, making sure all your joints are really strong, it should come out of the bisque firing intact without any cracks. However, there are things in the firing that can also cause structural problems such as cracks or warping. So following the prescribed steps as I recommend them based on kind of the chemistry of clay is going to help you avoid problems that you would not have had if you had fired the kiln correctly. So the chemical formula for clay is Al2O3, that is basically alumina, and 2SiO2, that is essentially silica or glass, and oops, this is a mistake. Wasn't paying attention. And 2H2O. So this is the chemical formula for clay. So alumina, silica, and 2 molecules of water. But in addition to that water, we add a lot of water to the clay. So to make it malleable and that wonderful plastic thing that we like working with. So that's called the water of plasticity. And it's the water that is just mixed with all your ingredients and nicely conditioned when you buy a bag of, or you make your clay in the studio. So most of the water plasticity leaves the clay by the time the clay's leather hard. And as a matter of fact, much of the shrinkage it's going to do before the firing happens once the clay has reached leather hard stage. There's also what we call pore water, also called atmospheric water. And that is just, it's still present in air-dried clay that's been sitting around the studio drying for a number of days. And it fills the pores between the particles of clay. And there's a certain tension in the clay that holds it there. And that water comes out slowly in the first 250 degrees Fahrenheit of the firing. So from room temperature, say around 80 degrees to 250 degrees, you're losing a certain amount of what we call pore water or atmospheric water in the firing. So that water, if it goes through the boiling point, which is around 210 degrees in Colorado, if it goes through that too fast, that pore water will turn to steam and cause your piece to blow up. That is probably the riskiest point in a bisque firing, and a time that you want to go through the firing very, very slowly. So the next thing you have, form of water that you have in the clay is what we call the bound water, and that is these two molecules of clay right here that are chemically bonded within the molecules of clay that are in your piece. So the bound water is is part of the chemical formula, and when that gets fired out of the clay over time, it's not as risky a time in the clay because it's not something that happens immediately, but it happens over between 840 degrees Fahrenheit and almost 1300 degrees Fahrenheit during the firing. So it's happening basically over the course of 300 degrees of temperature increase. What happens with that is after that bound water has left the clay at around 1300 degrees, you can no longer slake your clay down. You put it in water and it's not going to disintegrate anymore. And that's actually what we're looking for when we're trying to make our piece easier to bisque fire. We are wanting to make it solid and not easily disintegrating in the presence of the water that might be in your glaze, and that would get absorbed by the clay. So another stage that happens is quartz inversion, and that happens, interestingly, at a very specific time, which is around 1060 Fahrenheit. And what's happening during quartz inversion is your chemical structure of your clay is changing. So it goes from an alpha structure to a beta structure or something like that. I don't really know those details, but what I do know is that at that point, your clay expands 2% and the silica shifts structure. And then when the clay cools after the firing's over, it actually shrinks back down 2%, and then it goes back to the original structure. So that is a very stressful thing for the clay to have to withstand, and it's really important in bisque firing that you go very slowly between the temperatures of like 1000 and 1100. So what does all this stuff mean for your firing? Basically, it means that you need to go pretty slow from the point you start the kiln until about 300 degrees. And then gradually you might speed it up a little over the time between 300 degrees and 1000 degrees. But if you do speed it up at that point, you need to drastically slow it down between 1000 and 1300 degrees. And then after 1300 degrees, you can let the kiln kind of fire at a medium or rapid rate to its final bisque temperature, which generally in our studio is cone 06. However, occasionally we change that final temperature just out of convenience. If it's mostly our Los Altos clay, which is a really strong stoneware, it seems to really, for good glazing, it's fine with just going to cone 08, which is a little cooler, meaning that we're using a little less fuel. And then porcelain clays and our casting slip, Lauren's casting slip, is best if it gets bisqued a little bit higher because it's a little more fragile at the bisque stage. So we usually take that to cone 04. So you will discover that while I generally give instructions to bisque to cone 06, you can always slightly alter that final temperature to suit the needs of your firing and your specific clay. Now, the other thing is that our, a piece that you made that's very large and has walls that are ½ inch thick or maybe even a little bit more is going to be need to fire a lot slower and a lot more carefully than a bunch of things you just slip cast and they're only 1/8 of an inch thick, or maybe at max 1/4 of an inch thick. So, generally in our studio, I'll say this is for dry things that can fire pretty fast, and this is a slow firing or a conservative bisque firing. So you might wonder, like, why are there so many subtleties to how that bisque firing happens? It's because when I can get away with a faster firing, I'd like to, because it means I'm using less fuel and it's just better all around. However, plenty of times I want to fire really slow because there's something just is a little bit more at risk in the firing. So that's the basics of firing, a bisque firing. We will be talking specifically about how you implement these concepts in programming a kiln in the class with some worksheets and handouts that you will have that will help you go through all the steps of programming an electric kiln for bisque firing. If you'd like to a bisque firing in a gas kiln, I would like you to speak with me directly and we can talk about the steps for doing that. It's definitely possible and not that hard. It takes a little bit more attention to the kiln. But as I said, I'd like you to speak with me before you choose to bisque in a gas kiln, just to make sure that you've we're not going to have any issues. And then the last thing I want to say is we have 2 mechanically operated test kilns in the kiln yard, and those are really hard to bisque in. It's really easy to blow work up in those. And they take a lot of attention. You can't just turn them on and walk away. And those as well, if you choose to bisque in them, please speak with me first, or Lauren, or somebody who's experienced at bisque firing. Thank you.